No, so I'll just face that. Not sure if it's got enough clearance on the side there. Oh, not quite. Okay. Still a bit more to go. That's it. Put a bit of a chamfer on the end of here. Take the nasties off. Might think about drilling holes in here, hole in here. Probably better off to make the washers first. Cut them off so that it's obviously going to be hard to hold once you get down to that thickness. Leave them to last, that'd be probably slightly dumb. So we'll do that first. So what I'm aiming for is a 20mm hole, and it needs to fit nicely over the existing arbor. You can see that one fits, and it's slightly sloppy, slightly, so not a bad fit. That's what I'm aiming for with these, the centre hole here. It's good when you've got something that you're basically copying. Gives you all the dimensions that you need. So, change that to a bigger drill bit and I'll continue on. Buy these adapters, wheel adapters, Arbors. Thinking I might get them for about 35–40 bucks. But it's not the same as making it. Isn't that why we have our own machine shops that are at home? I don't do this for a living. My wife calls this my toy shop. I said, how dare she? This is actually serious business we're doing here. Anyway, battery's just about to run out of the camera, so take it for granted that I'll get to the bottom of the hole. Right, so I'm going to part this off now. This is one of our washers. Which is otherwise easy. So, going too fast or too slow? Let's slow it down a bit. Concentrate here, because last time I did this I smashed it off. I know what it is. I've got to put the blade in further. The problem with that is I've got to put it back out again, cut it off. See what extra speed does, in case I'm wrong. Probably going to go bang. Trying to let's go right back into speed then. It's just emphasising the same problem. Rightio. Have to stick that in further. So let's hope that changes the vibration. steel. It's a bit hard to get the perfect length. Let's try again. Let's go back to 350. Much at all, has it? Really is crap. Yeah, go down the slowest speed possible. There's a chance of grabbing me. Slow it right up. See if we can use a bit more speed. So what? Yeah, okay. Okay, next thing we have to do, I've turned it round, re-indicated it back in the forejaw, and I'm just going to face this end off. I'm going to drill it, and then drill it to the through hole and the size of the thread that's got to be tapped in there, which is an 8mm thread, and then we'll work on turning it down to this diameter here, and then I'll probably do the threading, and then recess it, tap it, cut it off. Okay, so what has to be tapped in the bottom of this little, halfway through this little piece here, is an M8 by 1.25 tap. If you go into the engineer's handbook, black book, under tapping threads, they're saying M8 by 1.25, tapping drill size 6.8mm. I want to drill this hole in 2 stages. I could just smash a 6.8 through, but I like to do a little bit of a pilot, so going with about a 5mm, and then I'll bore it out with the correct size for the tapping hole. So the depth that this has to be, given that we're doing 2 of these, so if it continues through a little bit further into the stock, it's only just going to be a starter for the second one. I think this was 37mm from memory overall. So what do we got here? Yep, 35.98, so 36mm. So as long as I drill in there more than 36, will be apples. Good. Speed it up a bit. So it's in gear. Okay, so now there's 6.8 drill bit down into around about 37 to 40mm deep now. We'll drill that one. When the flutes stop getting the chips out, because the deeper you go, the harder it is to happen. When it starts to feel like it's just starting to bind a bit, that's when I withdraw. Clear the flutes, a bit more oil, and go in. I do think that I'm now the right depth, because I think the amount of force I had to put on the drill just then was just started to increase, which means I'm probably at the bottom of the hole that I'd already drilled. Definitely. Okay, so that's far enough. Right, so I either turn this down now or I continue on and finish off the holes while I've got the chuck in. Maybe I'll do that, I'll drill that bigger hole there, work out its depth. Depth with the vernier, the old gasometer. I say none of this has to be precise. Let's try and get it as accurate as we can. About 6 mil. I just bumped that. It's just got back in. Anyway, about 6 millimeters deep. The diameter. I could get a dial bore. We've got telescopic gauges onto it and work out the size, or I could just run through my drill bits and see which one fits neatly. It's probably all it needs. It only needs enough to let a washer go past on that bolt. So anyway, we'll have another look in a minute. Rightio, so the what size drill bit? 12.5 fits in there pretty damn well. Sometimes drill bits tend to want to suck themselves in a little bit, so I like to put a bit of drag on the little lever that locks out the spins on the chuck, on the tailstock. Just give it a bit of a drag so it doesn't suck it in, particularly for soft materials like brass is one in particular. You'll just suck the drill in and then jam it, and then I've had it before with the whole chuck and everything's been rotating, but it's jammed up. So remind me to get some shorter drills. Okay, so that's about 6 mil indicated on the spindle barrel. Yeah, it's not quite deep enough. So the hard part about this, of course, is there's a camera tripod in the way. Trying to measure that. The only way I'm going to measure that is take the drill bit out. Let's make room for the. This is what I'm talking about. Drills like this. I just don't like these flats. It sort of like reduces the diameter of the drill even further, just so it won't spin. I prefer none of these flats. Look even better, I suppose. I'd get some more tapered ones, but I haven't got them. Should be on my list. It's funny, drills and things like that don't sort of end up on top of your list. It's always all the fancy stuff. Where am I? Lost it. There's 5. So that's 5.5. Next one round. It's going to be. Oh, sorry. Yeah, 6. So lock that off. And what do we got? Well, geez, it's damn close. Just see that rocking back and forward a smidge. Like if I go in another millimetre, I reckon I got it. So let's do that. Once again, it's not important. Let's do it anyway. That's it. Alright, next stage. Appeared I didn't press the record button. That's very handy. Oh, that's quite a nice finish. Wow. Wow, that is right, nice. Okay, so that is smooth as a baby's bum. So that was a 1.25 mil cut. off both sides, so halve it per side. It's a direct reading lathe, so what you dial up is what comes off the diameter or what travels the length, all that sort of stuff. So when I say 1.5, 1.25 or 1, it is whole diameter. But I can't get over how nice that finish is. They say carbide likes being pushed harder, so I am trying to push harder. I was thinking of speeding it up from 600 RPM to 1050, but that's quite nice. Alright, so taking up to 30mm in length off this, got to get down to about 20 OD. So long way to go. I think it was 50, started at 54. One and a half mil off. So what's that? 1 mil, 40 thou. Half is 20. So this is 60 thou cut. Probably as much as I'll ever normally push this lathe. Interesting. Now, chips aren't really flying off it. Let's experimentation. 1050 RPM. See if I get some power. I should lose power, really, shouldn't I? But anyway, let's try it and hit it. Let's see what happens here. This could be nasty. Oh, hell yeah. That ain't working. Rightio, let's go back to 350. I'm just trying to see if I can take that 60 thou cut off. So it's only a cheap smallish lathe, but let's try 350 RPM. Yeah, right. So I can do it. And now I've got big long chips coming out. They're not breaking off in the chip breaker. Now finish is probably going to hell as well. So, I've learned something. I think I can get away with 1.25 mil. 1.5 mil cannot. So where's back my zero? Back here. So let's go 1.25 mil. Not a lot of difference, but let's put it back up to 600 RPM. See how that goes. finish is still quite nice. I like that. Alright, I'll continue on until, what do we got? Just for the hell of it. Nowhere near. Ah, 47 mil. Only 27 to go. And that's the problem with the smaller lathe, I suppose. That's probably 20 passes I've got to do to get that down. Anyway, gives us something to do, I suppose. Rightio, now we've got the diameter down a bit. I can take a bigger cut. Taking about 1.5 millimetres. Total cut now, reasonably easy. So it's got more mechanical advantage, lesser diameter it's turning. And that's not set right. That is. Still doing 600 RPM. Okay, so we'll keep with the verniers for now. When we get closer, we'll switch to the micrometer. Rightio, what have we got? 33, nearly 34. So let's keep on going. Okay, we're at about 22.7. Check to see if I'm 0. Yep, rightio. Let's take 1.25 off. Let's go again. Okay, 20.34. Let's take off a smidge more. 0.15. .21, no, 21, start again, 20.19. How our washer, original washer goes on. No, still too tight, well, that's good then. So we'll pop that back to 0. I always reset my particularly crossfeed dial to 0 after every cut, because I can't remember where I was at sometimes. You know, if you take a 1.2 mil off, we at 1.2, does that mean the next one's 2.4? If you take a little bit less, then it's 1 point, you know, it just all adds up and gets in a muddle. I just prefer at the end of the cut, quickly reset your dial back to 0. That's where I know I am at 0, which is touching the job. So any advance from there is just going to be a smidgen or more or whatever above 0. Chips in my hair. Awesome. Right, we'll run that back out all the way through at 0. Probably won't cut for the first part. Bad habit, but I always like to wipe the chips off the end of the, it's probably not a good idea, but we do these things. Right, so let's take it on, but it's still a pretty nice surface. Okay, so, and there we go, 20.04. Rightio. Now the increments on my lathe, on the crossfeed, is 0.05. So that ain't much. Almost, not quite. That's the washer. Let's try a wheel. So the wheels have got to go on there. I think the closer you get this point here and the taper, oh, it's so close. Okay, so I'm going to have a crack at, so I've got file in the place, don't particularly like filing. Let's take this to halfway between the marks. This might not even do anything. Let's see. As expected, taking a tiny cut. I may have to file it for after this. Now we're getting down to silly margins. Okay, reset. We're turning it a tiny bit. Now, let's just try the objects that need to fit on it now. See, that's good. Let's try a wheel. Okay, it's probably a little bit too silly, so I might just hit it with a file a little bit. No? I'll hit it with a file. No, I'm going to emery. Got some emery here. What grit will I use? Let's go 240. See what that looks like. So it's a memory. Try and keep my body out of the way, line fire. So I don't get my hands in the way of the camera. So what's our official measurement? Official is, must be 19.985. So that should make a difference. So this one did go on before. That's the washer. Literally no sideways movement. Oh, can't even detect it. Let's try the diamond. Bit of a wobble. Go on. I think that's about as good as we're going to get. Try this one as well. It's got like a plastic. It's a little bit more stubborn, but better to be a bit tight than too loose. That's alright. So now we need to put these features in. So we've got the bearing surface there that's going to hold the wheel. Zip. Well, wheel. It only goes to go on one wheel, obviously. It's interesting how they've done that without a relief on the thread. That's fancy. That's CNC for you. So I now have to measure that out. I'll make sure that that measures the correct measurement from here out. It's funny, it's got like a little bit of a relief or something on the back side of that there. A tiny bit. I wonder if I could replicate that with a parting blade, that tiny little. And then we'll work out what that thread is. Thread it. We know what that thread inside is. That's an M8 by 1.25. Then we've got to turn around. Well, not turn it around. Then we've got to dock it off. Put that back in the forge jaw. Get it running perfectly with the dial indicator. Then we have to work on this little jigger in the back here, this tapered section. I've got an idea how I can replicate the taper on the compound. Obviously it's not going to be as beautifully smooth as what that is. Well, I don't have a tapered reamer. I don't even know what that taper is on that reamer. I don't know how you would measure it without trying different reamers. I really don't know. Yes, we'll keep on going. Okay, so I'm just turning down the outer diameter now for the thread. Bring it down to 18 millimeters. See what we've got now. 15, 16, 17, 18, 19. So 18.43. 18.43. So let's take off another, maybe 0.3. Mr. Micrometer out again. Okay. 18 point. Must have misread that before, maybe. Definitely is 18.5, 18.7. Must have read that wrong. So let me double check that. You only get one chance to stuff this up, so try it again. 18, and the next line it's over half, so it's got to be 18.7. 18.71. You can double check by grabbing the original, and this should go over this easily with a bit of a... So if you ever get confused and you can't believe your instruments and you've got something to measure it against, just in case, like obviously I made a mistake on the first one. I said it was smaller than it was. It must have been 18.9 something. So we've got 0.7 of a mil to go. So we can be a bit more adventurous. I do like usually to use my parting off tool to put an initial stop as to where stuff has to be ended, but I'm now down to the depth that I'd already used the parting tool. So what do we got now? Okay, 15, 16, 17, 18.39. Right. Right, let's give that a wipe down with a rag. What have we got now? Ah, 18.21. Check it against our original. Yep, definitely got some play in there. Okay, so that's 9/7. We'll just drop the shifter on the floor. Put another, lost my chamfer, we've taken that off. Put another one back on. Okay, so first of all, let's put our parting blade back in there. Put in a relief for the thread at the end. So I've got somewhere to stop it. So this is how I square up my tools. I run it up into the chuck and get it square with Mr. Chuck. Tighten it up again. Right, so that's now square with this face of the chuck, so that's got to be reasonably good. So this is going to be the relief. I'll zero out my dial. And according to our little book, it says the minimum 18 by 1.5 basic minor diameter of external thread is 16.16 mil. So I have to make that relief a smidgen smaller than that. So if that's 18, let's take off 2 mil. That'll be a bit smaller. So let's just lower the speed on this to 200 because I feel it's going to chatter. Get in the gear, come on. Right. Let's try that. Camera happy with that? Yep, maybe. Right. So wind in until we touch off. Yep, so this is a direct reading lathe, so I need to go in 2 millimeters. And that'll be a relief for the thread. Okay, so now I need to prepare the lathe to cut the thread. That means go in the back of the machine, change gears to 1.5 pitch. So yeah, there goes 5 minutes of wasted time. Get yourself a machine without change gears. Right, so lathe is now set up 1.5 pitch according to the change gears. If you had a machine that had a gearbox, that would be even better because you could select it through just the levers. So got a thread pitch gauge here. May or may not focus on that. 1.5 pitch. So now I'm just going to do what I call a scratch pass, just to confirm that I have everything set up right. Right, so back to 0. And one thing I forgot to do is set my thread chasing, or whatever you call it, dial down onto your lead screw. So I'll quickly do that. I always swing it out of the way when I'm not using, so it doesn't wear. It's okay, we should be good now. Oh, look at that. That's what happens when you don't put it in gear properly. What's gone on wrong here? Something's gone wrong. Let's have a look at the back. Okay, sometime later I've worked out, well, change gears disengaged themselves in the back of the machine and would not want to go back together, so I really don't know what happened there. There are 2 sets of main gears that give you a high and a low. We end up having to change those out to pick up the 1.5 pitch on the high side, whereas normally the low. Don't know why. Anyway, eventually I've got it going, I think. Once again, change gears suck. Right, so let's do that scratch pass. Okay. Checking with the thread pitch gauge, it's a little bit hard to show, but basically little points on your gauge line up with the scratches made, so we are definitely in 1.5 pitch territory. That seemed to work. Let's have a bit of a look. See if our nut will go on. Nut is on. Okay, so that's done. Let's file that off a bit. make sure the nut is still happy. Yep. Okay, decision time. How am I going to cut this off? I'm going to try and cut it off with a parting blade. So I got one tip left and one half of a blade left. I haven't ordered another one yet. Can I get it into the bandsaw? Cut it off a smidgen long. Don't know, I don't think the bandsaw is really going to be an option looking at it. I'll have a think. Okay, so the decision's been made. Going to have to be cut off in the lathe. Won't fit in the bandsaw, as in the bar that this is attached to is too short. So it cannot be held in the vise properly. So we'll start off in low gear. Okay, so survived the parting off. Slippery, slippery, slippery. So, parted off with the parting blade, worked alright, took it very slow. Now I just need to mount that back in, four-jaw, accurately. And then we can start working on the taper. Then tap that hole and it'll be finished. Then another one to make. Right, so I've got a little bit carried away and blasted ahead without thinking about the camera, but that doesn't matter. So what I've done is just widen that a little bit. I've set the compound to the angle via a test indicator. So I had that set in here, put a test indicator, and I kept moving this in and out until the test indicator didn't move, the needle. That indicated that this was on the same plane as the existing taper that's in here. So now what I need to do is continue with the boring bar. The way I could work out how to replicate the size of the opening, because I've got the taper set, I just need to know the size of the maximum opening here, which will obviously indicate and the depth, it'll end up just being the same, is with this telescoping gauge, is to get this set just at the opening, just to fit in, and then it'll be the same. If I can replicate the same feel here, it's got to be close. The actual part that this sits on is on the machine, so unless I take this all out and get it all out of indication, like out of, you know, I have to put it back in again and try and re-indicate that perfectly, or hold the machine in here and try and, it's the only way I can think of doing it, and I'm sure it's going to be fine. So that's what I'm aiming for, is to get that feel in here as to here, and that's got to be about right, and then we'll try it on the machine and see what it's like. Still got a good amount to go. I'll keep going until I'm looking for get the feel that I'm looking for. Okay, so I've got the same, all I can describe as is feel, with as how far this telescoping gauge sits inside this original arbor to the one that I've just machined. To me that feels the same as far as how deep this is going into it. If I had tapered reamers and I knew what that actual taper was, I suppose you could just use that, but when you don't have this gear, this is all you can sort of do. Here's the finished article. Another arbor, fit the D-bit grinder. Here's his buddy. This one here is one that I copied. Now, as discussed earlier, mine's got a bigger diameter because I had a bigger stock that I was starting with, and it had made no effect up in here, so why machined it off for no real particular reason. So I'll put this together on this wheel, the diamond wheel, and as far as the fit goes, it's very tight, which is good there. Goes a little felt washer. This is my spacer that I made, washer, I suppose really. This is still the original nut, so I do have to make this as the next part of the project to finish one complete arbor setup. I do have the stock ready to go to do another arbor. So that's in there. Do up with a little spanner. Now, I do have to tighten up a bit more once it's on the machine. So, that taper goes up into that taper on there. Which you can probably see there now. Pop him up on there. 6mm bolt holds it all together. My little tool for getting it off for getting it off with, I haven't added an Allen key to it yet, so I have to break out the Allen key set, Allen wrench, whichever way you want to call it. Do him up. Now with these, which if you have one of these you'd already know, over the back here there's a little spot here where a grub screw or cap head screw goes in. That's just to block off the hole. You use another something, a pin or smaller Allen key, to go into the centre of the shaft, and there's a hole there. There it is. Now that allows you to lock this off so you can tighten up. Sort of locks the shaft. Have to be very careful, of course, to make sure you don't start the machine up to that pin in there. That might not be good. So let's just take him out. Pop him back in here for the moment. Well, actually, didn't I say I needed to tighten that up more? might just do that. Maybe it did. Don't know. Might have cut that out. That might have been a load of crap. Right. Take that back out. Okay. So. Fire it up. Let's be brave. Let's not worry about if it's running out or not. Just give it the herbs. Give it the berries. Clear. Okay. So I can feel a slight bit of vibration. Looking at this when this slows down, I'm not seeing this surface here wobbling, but I am seeing the diamond surface seems to be a bit thicker, almost like it's not glued perfectly concentric. Let's check with our dial indicator. I'll let that guy pop down and get it right out of the way. Okay, so I mentioned it before, but these dial indicator bases are so cool. With the angle, I've got that all set up there. He'd be mucking around for bloody 5-10 minutes to try and use this style of base. Oh, that might be alright on a surface plate or something where you don't have to really worry too much about trying to get into weird spots, but yeah, these are great. Doesn't have to be this brand. I know Starrett do them. Now there are some off-brand ones too. Okay, so what sort of run out have we got? Let's have a bit of a look here. Let's set that to 0. Let's move Mr. Camera. Right, so these are, each increment is 1 thou by the look of that. So there's 1, 2, 2.5, nearly 3 thou run out. Okay, so let's just move this again to the diamond part of it, which I can definitely see moving, or have before. Now, so this is on the diamond edge. Probably not a real good thing to do with the end of the... Well, there you go. That's gone to 6 thou, 7, 10, 12. Yeah, so to minus 10, 11, 12. So that's the diamond edge. So not a lot you can do with that, I suppose, but maybe you don't use it. Doubt you'd be using that part of the diamond anyway. Not for much. So let's set this up with the original and see if we get nearly the 3 thou run out that this had, and see how much worse my new Arbor is compared to the original. Okay, so we've got the original Arbor set up back in the machine. There's the one I made. Let's see what the run out is on this one. Possibly, if I can get the tripod out of the way. That's sort of focusing. It's 1. So +1 to minus nearly 3. So actually 4 totally out. So certainly within spec. How I built it was as good as the machine one, and it just could come down to how it was put on. You know, there's a tiny bit of play in each one of these when you put the Arbor through. So yeah, I certainly didn't make mine any worse, which I'm pretty happy with. Now I need to make that nut, that little fella there. So look for a bit of bar stock, similar size. Once again, doesn't have to be that diameter because it's not really going to foul anything. Yeah, we'll keep on going.